All right, number 3, we want to determine whether 147 is prime. So one of the descriptions that you'll see in the text say that a number is composite, which means it's not prime. So you got prime numbers and composite. Composite is just a number that's not prime, and prime is. But it shows this definition: p squared has to be less than or equal to this number. So I'm going to use 147. Now we can use the divisibility test and check and see what this is divisible by, but I just want to kind of explain this definition as well. It says if it's going to have a prime divisor, it has to be one of those primes that if you square it, it's still less than this. So if we do 2 squared, we get 4. It's definitely less than that. 3 squared, we get 9. 5 squared, we would get 25. 7 squared, we would get 49. 11 squared, we would get 121. 11. Okay. If we went up to 13, that would give us 169. That would be bigger. So these are the possible numbers that will divide. It has to be some kind of prime factor, or every number can be written down in prime factor. So if it's going to be divided by one of these numbers, or if it's not prime, or if it is prime, if it's not prime, it will be divisible by one of these. Otherwise, it would be prime. All right, so we can get rid of 2 because it's not even. We can get rid of 5 because it doesn't end in a 5 or 0. So we can check 3, 7, and 11. So let's see if it's divisible by 3. I'm going to add up these digits. 7 plus 4 is 11, plus 1 is 12. 12 is divisible by 3. So this number is divisible by 3. 147. Let's divide by 3. 3 goes into 14 4 times. 3 times 4 is 12. Take away 12. That will leave us with 2, 7, 27. And 3 will go into 27 9 times. So it's divisible by 3. So that means it's not prime. And if we broke this down further, 49 is 7 times 7. So prime factorization would be 3 times 7 squared. So the fact that it's divisible by 3 means it's not prime. It's also divisible by 7. So no, this number is not prime.